Hi, I'm Andrea Marchesini, Oracle Cloud Infrastructure Product Manager. And in this OCI QuickStart session, I'm going to provide a high-level overview of Oracle Cloud Infrastructure services and feature. Safe harbor statement. Okay, so Oracle Cloud is offering a wide set of services spacing from software as a service to infrastructure as a service, from ERP and solution like HCM or APM to a complete set of data management services, application development, and obviously core infrastructure services. All these services are running on top of Oracle Cloud Infrastructure. So, in short, Oracle Cloud Infrastructure, or OCI, is the Oracle Cloud platform that we are using to build and run and provide all the Oracle Cloud services. So it's a sort of, it's not just the infrastructure as a service offering, but it's also the platform, the glue that put together all the various components and building blocks. The Oracle Cloud Infrastructure is hosted in regions, where a region is a geographic area composed by several data centers. As you can see here, this is the current situation. We are having three regions in North America, Oslo, Phoenix, and Toronto. Two regions in Europe with London and Frankfurt, and now two regions in Asia Pacific with Tokyo and Seoul. Along with the regions, we also have around 20 geographically distributed point of presence or POPs that are point where we are running, that we are using to run edge services, as well as components needed by our backbone to interconnect all the various regions. The plan that we have for this year in terms of region expansion is to open at least additional 6 regions. As you can see, in Zurich, Saudi, São Paulo, Mumbai, Sydney, and another one in Japan. And so this is, I think it's a clear sign of the commitment and also the level of investment that Oracle is doing in OCI. That's, because this is, as I said, it's going to be the single platform where every other Oracle Cloud service is going to run. The overall design of OCI is built with the concept of high availability, fault tolerance, business continuity in mind. So we are offering a set of different features and components that allow our customers to build high available and fault tolerant application and workload on top of OCI. Starting with the concept of regions, where regions is going to offer protection for disaster and together with data residency compliances. So in order to be sure that you can run and store your data, especially for data regulated market in exactly the geographic area where you meant to do that. Also, together with the regions, and we will go a little bit more in depth about availability domains and fault domains in the next coming slide. We are offering two different components that are providing the possibility to design high available architecture. The availability domains that are offering protection from entire data center failures, and together with fault domains that are offering protection against failure within a data center. Putting together all these different elements and features, you are able to really decide what level of high availability and fault tolerance you want to put in your workload. Those capabilities are also allowing Oracle to be able to offer very unique set of service level agreements. So you may be familiar with the concept of service level agreements. Usually in a public cloud provider offerings, it's possible to find SLA for availability. So this is pretty common. But what is absolutely unique in Oracle offering is the possibility to have also SLA on performance and manageability. So this means that we are not only going to cover giving credit back in case of lack of availability of the services that you are running on top of OCI, but also our SLA are granting the manageability, so you will be able to interact with the API, and performance. So if you will not be able to reach the performance that we are stating in our SLA contract, this will be covered by the SLA's contract per se. But now let's take a look at how we built OCI and how we are able to offer these kind of characteristics. So starting from a region. So a region can be composed by one or more data centers that are called availability domains, I mentioned earlier. ADs are completely isolated from each other and fault tolerant, so cannot be impacted by failure to other ADs, and are also unlikely to fail simultaneously, as are spread geographically in the metro area where the region is located. Inside each AD, we have built a flat and very high-scale physical network, which is not oversubscribed. So we don't run into issues like noisy neighbors, and also we are able to provide an extremely low latency between hosts in AD. On top of this physical network, we have implemented a virtual network with a very unique feature that is called off-box virtualization. This basically means that we have moved the storage and network I/O out of the hypervisor into the custom silicon card. This enables nearly zero virtualization overhead, And at the same time is decoupling the OCI control plane and the hypervisor that runs customers' instances. So granting a very high level of isolation, so security, and also allowing Oracle to be able to enforce the performance and to provide not only high performance, but predictable and consistent level of performance. This is something that is really important when we are going to implement enterprise workload that are not just looking at the performance per se, but they want to be sure that the level of performance is consistent and predictable. This approach of box virtualization also allows us to plug in the network nearly everything that is having a network card adapter. So on top of the same virtual network that span across all the availability domains inside the region, we are able to offer from the virtual machine to proper bare metal node, where you are having a full control over the bare metal box, as well as various offering around database from rack VMs with or without rack up to Exadata. As well as the various services like all these storage services, load balancers, and also a very high level of security because we are able to control and to isolate, as I said, the control plane from the hypervisors that is running the customer's instances. Inside OCI, as a main building block, we are offering different set of services that can be used then to build your own workload and to run every kind of application or workload on top of OCI. We will discuss more in detail about many of these during this presentation. Now, just to mention some, we will have obviously compute services where we are offering both virtual machine and bare metal nodes, both will be based on Intel and AMD CPUs as well as NVIDIA GPUs. We have a wide set of storage services. Obviously, a very complete offering around the database, both with the autonomous database as well as the DB system. So different approach to the Oracle database. And again, networking, containers, and so on and so forth. Now let's start to take a look at the main services, the core infrastructure services that are needed to build every kind of workload on top of OCI. And I will start talking about the IAM, or Identity and Access Management. This service enables customer to control who can do what inside the OCI account. It's based on the concept of semi-permanent principals that can be the users and instance principals, depending if you are interacting, if there is a human being that is interacting directly, or if you want to provide authorization to your application via instances. And then we have the identity access management offers the possibility to control and manage the authorization with different level of authorization, so username and password, as well as the API signing key if you want to access programmatically and interact with API, SDK, Terraform, and so on and so forth. As well as the auth token that is meant to provide authentication while working with third parties APIs. Once you have authenticated your principal, then you have the control of the authorization. So authorization is provided by a human readable statement, or that are called policies. And what is important to note is that the approach that we followed when we have built the OCI Foundation is always the approach of least privilege. So in this case, this means that a user per se is not able to have any interaction with any resource inside the OCI. You need to put the user in a group and then associate to that group a specific policy in order to allow any kind of authorization to the user. We also introduced a pretty unique concept called compartment that is meant to provide logical boundaries between resources in order to provide the possibility to organize and isolate set of related cloud resources. On the identity access management, we are also offering a set of features that are meant to provide a better way to enforce governance around the various resources inside the OCI. Among the various features, I would like to highlight the possibility of using tags. So I bet that most of you are familiar with the concept of tags. And together with the concept of a free-form tag, so the possibility to associate a key value pair to each resource, you also have the possibility to use a defined tags, where you are having a predefined schema that is managed and it's managed and predefined from users that are having the privilege to do that, and then can be just enforced in the various resources, both automatically with a default tag concept or manually from the various users that are provisioning resources. Last thing that I would like to mention is the audit service. That is a service that is collecting and recording all the interaction with the API endpoints. So this basically allows you to really have a full control and a full track on what's going on inside your OCI account. The first time that you are signing for OCI, you will find a tenancy that is basically is is basically a root compartment. This will, the tenancy represent the full OCI cloud account. Is a global concept, so the tenancy can then be, it's available in all the same tenancy is available in all the regions that you decide to subscribe to. Inside the tenancy, there is an administrator, a pre-built administrators group with that is containing the administrator users, that are the ones that are indicated in the contract, in the initial contract, and this will be the first user that are meant to administer and manage all the resources inside the cloud, the OCI account. The groups is associated with the default policies that allow the group administrator to manage all resources in tenancy. So obviously this is to grant you the possibility to control the cloud, the OCI cloud account itself. Then once you log in, obviously you can start to create multiple users, groups, different policies, and slice your tenancy in multiple different compartments. You can have also nested compartment up to 6 level. Let me just quickly jump on my environment. Just to show you a couple of things. So this is the home page for Oracle Cloud Infrastructure. As you can see, you can find a set of quick action that are basically shortcut to provide you a fast access to some of the services, the most used services. But now let me jump on the identity part, just to show you how you can create users group and associated policy. So I'm now working in the compartment QuickStart, that is a sub-compartment of the compartment training. So this is the compartment I already built in advance, and I'm going to work on this today. And now let's create a user. Start user. Each and every resource can be associated with a tag. So let's see, QuickStart true. And the user is now created. Now this user, QuickStart user, is not able to interact with any resources, not any kind of authorization. In order to provide whatever authorization, so let's imagine that we want to provide this user the possibility to control the compartment QuickStart, so to manage that specific compartment. So I'm going to create a group. Let's see, QuickStart group. I can add a tag also here. And once I have the group, I'm going to add the user QuickStart to this group. Obviously, each user can be part of multiple groups. Once I have the user and group, the association between user and groups, the last thing that I need to do to provide authorization is to create a policy. So let's create a policy. QuickStart policy. QuickStart. And the policy will be something like allow group QuickStart group to manage all resources. When you are defining resources, you can specify a single resource, a family of resources, or the entire set of resources available on OCI with the special keyword that is called all resources. In compartment, QuickStart. Okay, now the user QuickStart is able to manage all resources to provide, to provision any kind of resource inside the compartment QuickStart. So each resource is associated with a specific identifier called OCI ID. So as you can see here, each resource, in this case, the policy is associated with that specific unique identifier. And this is really important, especially if you are going to interact programmatically via command line interface, SDK, and so on and so forth. So those are elements that you can find that obviously you can get from an API call, so via CLI and SDK, as well as from the interface. So this is the way you are going to define, identify the various resources. What is important to say while talking about identity and access management is that all the resources that are part of this service are global resources. So this means that are immediately available in each and every region you are subscribed to. So as you can see here, I'm working in the Frankfurt region. But if I'm going to move in a different region, let's say I'm going to move just to show you in Oshburn, I'm still seeing exactly the same users, QuickStart users, exactly the same groups, and so on and so forth. So the scope, this means that the scope of the identity and access management service is a global scope, and this is how you can interact no matter the region where you are in. You always will be able to find all the definition related to the identity and access management. We will see later that this is not true for all the services. Let me go back on Frankfurt. Okay, and go back. Okay, network services. So the network that is the virtual network that you can run inside OCI is we are calling it virtual cloud network, or VCN. And basically, you can define your VCNs inside your account using single contiguous IPv4 CIDRs. You can create multiple VCNs, and each VCN, and those are isolated from each other. Inside a VCN, then you have all the components and features that are allowing you to design your network and to control the flow inside your network in terms of routing with the route tables, as well as security with defining ACLs with the security list that are allowing you to isolate the traffic. You can then you can use and define multiple network interface to be used and to be attached to your instances, and you have the possibility, obviously, to use both private and public IPs, both ephemeral and reserved, and then you can leverage additional advanced service, advanced network service like load balancer that is offering both layer 4 and layer 7 with TCP and HTTP load balancer, with the support also to content-based routing, SSL, session affinity, and so on and so forth, as well as the possibility to manage DNS zones and records directly from inside the OCI account. Also, there are a wide set of gateways that you can use inside your VCN and inside your network layout, and all those gateways are logical construct that are offered as high available components by the platform itself. So you don't need to worry about the redundancy of the various gateways. This is a list of the gateways available. So starting from the top, Internet Gateway is a bidirectional gateway that allow your instances to be in communication with public internet, both to reach public internet and be reached by external public internet. Then we have NAT Gateway that is providing, in this case, a mono-directional connectivity with internet. So in this case, if you want to provide the possibility, even from inside the private subnet in OCI, to connect with external public internet host, then you can use the NAT Gateway. Service Gateway is a gateway that allows a private connection to OCI services exposed by a public IP, bypassing the internet, so it's still private. Sorry. Then we have a set of gateways that are all part of the DRG dynamic routing gateway, and are the possibility to connect with a private, with remote, basically with remote remote host in a private way, so leveraging IPsec VPN as well as Fast Connect, but also the possibility to establish a peering between different VCNs that can be local between VCNs that are in the same region, or remote between VCNs that are in a different region. In this case, again, is a connection with a private connection with a remote host, so it's still depending on the DRG. Let me jump on my environment again. Okay, now let's go to create the network. So I'm going in networking, virtual cloud network, and start to create a new VCN. So this will be my QuickStart lab VCN. When you're going to create a VCN, as I was saying, you have to specify a single contiguous IPv4 CIDR here. You can also decide to use the wizard to quickly create a VCN that contains also the main resources needed to interact with public internet. So in this case, we will go with this one. It's just faster in terms of creation of the various components. If I'm selecting create virtual cloud network plus related resource, the wizard will provision for me a VCN with a CIDR 10.0.0.0/16. We'll create an internet gateway. We'll update the default route table in order to let the traffic flow through the internet gateway in order to reach public internet. And also we'll create 3 subnets. Let's create our VCN. This takes just a second. Indeed, it's already up and running. Now I am inside the VCN. If you look at the VCN, what has been created here, I can find 3 subnets, and those subnets are availability domain subnets. So the scope of those subnets is just related to availability domain. You can also create subnet regional that are regional. So in this case, obviously, every time you are defining a subnet, you need to define a CIDR that is a subset of the CIDR that you use to define your VCN. So in this case, I'm getting 10.0.10.0/24. You need to associate a default route table. You can decide if you want your subnet to be private or public. So this basically allow you to define at creation time if you want to provide the possibility for the compute instance that will be attached to this subnet to have public IP associated in case of public subnet, or to prevent to any public IP associated to the instance inside this subnet in case you use a private subnet. And that's it. You have then to define your default security list and create the subnet. As you can see, in this case, this is a regional subnet. So you can use both of them depending on your workload and on the layout of the network that you want to realize on top of OCI. Just very quickly, let's check the other component that has been created or updated for me. So the default route table is always created when you are going to create a VCN. In this case, the wizard just added this rule. So it added the possibility, the route rule that let the traffic destinated to 0.0.0.0/0, that is basically it's public internet or every that's used to indicate public internet via the internet gateway. Obviously, you can manage your your root rules, adding additional rules depending on the various gateway that you have defined inside your network. What is important to say is that the routing and the root rules are meant to manage only the traffic that is flowing outside the VCN. The traffic inside the VCN is automatically managed by the control plane, and you don't need to define any rules to manage it. The other component that has been updated for me is the default security list. In this case, in the default security list, I just have the port 22, so the SSH port open, so I'm able to reach the instances via SSH, and that's it. What is important to say about the security list is that security lists are defined and attached to the subnet, so are defined at VCN level, attached to the subnet, are enforced at instance level. So this means that in order to talk to each other, instances even inside the same subnet need to have a security list that allow that connection, that traffic. Sorry. Last component that has been created automatically for me is the internet gateway. As I said, this is a logical construct that is already redundant by design. So as you can see, I cannot create other internet gateway because it makes no sense to have multiple internet gateway, as this is already available and it's usable and available in the whole region, because the scope of the various gateways as well as the VCN is always a regional scope. Okay, compute service. So the compute service is offering the possibility to provision both VMs and bare metal instances, where a bare metal instance is a proper bare metal box where you have a full control over the full box up to the firmware, and it's usually meant to be used for high performance workloads. It's possible to run most of the Windows and Linux workloads, and it's also providing a very flexible way to size the instances itself. As I was mentioning earlier, we are supporting both Intel and AMD EPYC processors, as well as NVIDIA GPUs. When you are going to provision compute instances, you are able to select from a wide set of options, from Oracle provided images to custom images that are basically a sort of golden image that you can save, export, and import in your in your account, as well as doing bring your own images. And with bring your own images, you can also do bring your own hypervisor with Hyper-V, KVM, and OVM. It's also possible to leverage the compute functionalities to manage the scaling capability, horizontal scaling capability, that provide an easy way to manage auto scaling both in and out, and as well as leveraging a really fast provisioning time that allow you to create very rapidly multiple instances in case of workload that requires very rapid and flexible scalability performance. Each instance is coming with a predefined amount of network bandwidth that is non-oversubscribed and reserved to that instance. So in this way, you have an easy way to design your workloads with a predictable, a consistent performance. Let me just move on my environment. So let's create a compute instance. Okay. Create an instance. When you are going to create an instance, obviously you need to name lab instance. You have to select an availability domain. The compute instance are availability domain specific resource. So this means that are living in a specific availability domain. So I'm going to select availability domain 2. Yeah. Then you have the possibility to select the image, the source image that you want to use. There are plenty of source images. There are the platform ones that are based on sort of one provided by Oracle, based on Ubuntu, CentOS, obviously Oracle Linux, as well as Windows Server from 2008 up to 2016. Then there are a set of Oracle pre-built Oracle Enterprise images that are containing, as you can see, Oracle database, the NVIDIA GPU cloud machine, Oracle Linux for KVM, and so on and so forth. Plenty of them. Also, there is the possibility to select and start from a partner image that are coming from the marketplace, as well as use custom image, if any. So if you created any custom image, you can start a new provision a new instance from that custom image. Or if you are having a boot volume that you preserved from a previously created and terminated instance, then you can use that boot volume to start your own compute instance. So I will select the default. Select image. Then you can select the instance types if you want virtual machine or bare metal, and this is basically the only difference that you are having while while changing between virtual machine and bare metal. So even if you are going to have a proper bare metal box, that's the only difference that you have in during the provisioning. Then you can select your instance shape. When you select shape, you have each shape is identified by the number of CPUs and with a fixed ratio with the amount of memory. And as I was mentioning before, there is also a specific network bandwidth that is non-oversubscribed and dedicated to that specific instance. Once you select the shape, you have some option for the boot volume, if you want to change the boot volume size, if you want to enable the in-transit encryption. So by default, and we will see later while talking about the storage, by default, the boot volume is encrypted with an Oracle managed key. Then you can select to use the key management service to encrypt the volume, so to be in control of the keys, as well as activate also the in-transit encryption, so not just encryption at rest, but also in transit. Then obviously you need to provide the SSH key. And provide the information about the networking. So which is the VCN where you want to provision your instance, and which is the subnet where you want to provision the instance. So as you can see, you can select or the regional subnet or the subnet that is specific to the availability domain 2, because I selected the availability domain 2. So let's pick the regional one, and that's it. You can then create your compute instance. It will take a few seconds to come online. In the meantime, we can just take a look at the various information that you can see in this in the compute page. So this is the full domain. I didn't select it. I can. There is the advanced option. If you don't select the full domain, then this will be automatically selected for you by the control plane. You can find here the private IP address that obviously is part of the subnet CIDR range, as well as the public IP address that has been associated, because this instance has been created inside a public subnet. As you can see, the instance is now up and running, and from here you can stop, reboot, terminate, and so on and so forth. Okay, storage services. In OCI, we have a wide selection of storage services, starting from the local NVMe SSD storage that basically provides the possibility to have a local attached to the instance, no matter if bare metal or VMs. And this obviously provides a very high level of performance with a very low latency, and is having also a service level agreement on the performance. Then you have the possibility to use a persistent, still high performance and durable block storage. That is it's providing a very high very high level of performance together with a really aggressive price. And the way is you can look at the performance offered by the block volume service are linear performance. So based on the size that you are provisioning, you will have the performance that will be increased linearly. Then the block storage is actually used to provide both the block storage per se and the boot volumes, so both the block volume and boot volumes. And on top of the block storage service, you can leverage also advanced feature like clones and backups, where the backups can be automated or on demand. And those two characteristics are offering the possibility to create clones or backups in a really easy and fast way. Another service available on OCI is the file is the file system storage, or FSS, that is providing an elastic, durable, and enterprise-grade file system that can be attached via NFS, and is providing the possibility to scale up to 8 exabytes without any upfront commitment. Even in this case, the price performance ratio is leading in the industry. Last but not least, we have an object storage service that's offering two different tiers: the hot storage and the cold storage, that is the archive one. The first is meant to be used for data that are live data that you are interacting with. Instead, the archive storage is meant to be used for long data retention of your data. There are, even for the object storage, advanced capabilities like the possibility to activate cross-region copies to manage the life cycle of the object inside the storage. So basically, if you want to move after a specific amount of time object from the hot storage to the archive, as well as the possibility to create pre-authenticated URL or leverage the multi-path uploads. That is a built-in feature inside the API. And let's go to create a block volume. Okay, so let's create a block volume. QuickStart block volume. Even in this case, the block volume is an availability domain-specific resource. So you need to select which availability domain you want to provision your block volume. You can select the size of the block volume, starting from 50 gigs up to 32 terabytes, and you can attach up to 32 block volume to an instance. So basically, you can have up to 1 petabyte per instance. While provisioning the block volume, you can select if you want to activate backup policy. There are different backup policy with different frequency and retention time. Or this is something that you can activate even later. By default, the volume is encrypted at rest with Oracle managed keys. If you want to use the key management to manage your own keys, you can select this one. Obviously, you need to activate the key management service before. And then you are ready to create your block volume. Once you have your block volume ready, that can be attached to an instance, and you can easily create backup and clone of the block volume from here. The backup is going to be stored in the object storage. So this means also that you can easily restore the backup in less than 1 minute in each availability domains inside the region. And the clone instead is creating an immediate usable new block volume in the same availability domain. Block volume, it's up and running. When you are going to attach the block volume to your compute instance, let's try it. You have the possibility to attach it in iSCSI mode or para-virtualized mode. So the main difference is that if you are going with iSCSI, then you need to control the iSCSI protocol in order to attach and then mount your disk. This will provide the maximum performance, but sometimes can be you can find some workloads, some OS that is having some issue in managing the iSCSI. So you have also the option to use the para-virtualized mode. That is, as the name is indicate, suggesting, is providing a light para-virtualization just to hide the complexity of the iSCSI. Again, you can select the block volume. Now I created the block volume in availability domain 1, and we are in availability domain 2, so I'm not able to connect any block volume, sorry for that. And then you can, if you want, you can select the device path, so how you want to reach the, which is the device path that you want to use inside your OS while working with the block volume. And when attaching, you can define if you want to go in read-write or read-only mode. Okay, database services. So as part of the Oracle Cloud Infrastructure offering, we are providing a very wide set of options for you to select where to run your database, your Oracle database. So we are having the possibility for you to provision autonomous database, that is the autonomous database that is also autonomous ATP, transaction processing, or ADW, data warehouse, is offering a completely automatic tuning, patching, managing of the backup with an availability of 99.995%, together with a really fast provisioning. And this is an Oracle managed service offered on top of OCI. Or you can go with DB systems, that is a comprehensive set of offerings that span from VMs to racks to bare metal to up to Exadata, that are meant to cover every kind of workload, from the small dev and test up to the mission critical enterprise workload on top of OCI. There is a full support to rack and Active Data Guard, and also you will find a complete set of tools that help you to manage the full life cycle automation of your database inside OCI. Looking at this table, you can see the main characteristics of the various instance type for the DB system. So in terms of scaling, if you are using the virtual machine, you will be able to scale up the storage from 256 gigs up to 40 terabyte. If you're using the bare metal, you can scale the CPUs. The bare metal is using a local attached NVMe disk, as you can see here. So you cannot scale the storage because you are already using all the storage that is locally attached to the bare metal node. But you can scale the CPU starting from 2 and up to the maximum number of CPUs available in that specific bare metal box. And with Exadata, again, you can scale CPUs from 0 to the maximum numbers of CPUs available, depending on if you are getting quarter, half, or full rack. And the storage cannot be scaled because, again, you are using all the available storage. In terms of the number of databases that you can run, virtual machine are offering the possibility to run just a single DB with a single DB home. Instead, both in bare metal and Exadata, you can run multiple databases. From rack capabilities, this is available both in virtual machine and obviously in Exadata. And the data guard, the automatic provision of the data guard is available for all the trees. We very recently released the data guard for the automation data guard for the data guard for the Exadata. So now it's available for all those three. Let me jump again on my environment. This will be the last jump. Just to go on the database area, as you can see, you can from here both provision an autonomous database, and the provisioning of the autonomous database, it's really, really simple and fast. Basically, you just have to select a display name, can be QuickStart, select the number of CPU you want to start with, the amount of storage, and then just get a strong password, but I think this is not going to work because Oracle database requires. Let's try. Okay. Okay. Once you have done this, you can create your own autonomous database, and this will be ready in a few in just in less than a couple of minutes. When one thing that I didn't mention earlier that is important to say is that both for the autonomous offering and for the DB system offering, you can select if you want to bring your own license, if you already have a license, or if you want the license to be provided together with the service. If I'm going now on the DB system, within the DB system, so the main difference we saw before are that in the autonomous is a fully managed service. The DB system is an automated service, so you still be in charge of the database. You will still the administrator of both the underlying instance as well as the database. You will be still the one that will decide if and when to apply patches and manage the backups and so on and so forth. Leveraging automation tools. So this is one of the main difference between the two services. So even here you have to select QuickStart. The name, QuickStart DB, select an availability domain. Then you can select which shape type you want to use. Let's go with virtual machine. It's not okay. I already reached the service limits in my tenancy, so I cannot create any additional one here. Anyway, you can select the shape and select the edition that you want to run. With the CPU core count, it depending on the shape. So when you are going to select a virtual machine, you will be immediately associated with a certain number of CPU that are the CPU based on the VMs. Then the license type, again, if you want to go with the Oracle included license or bring your own license, and information about the network, VCN, hostname, and so on and so forth, password for the database, and then you are ready to create your DB system. And this will take around 30 minutes to be up and running. Okay, let me jump on my environment again and take a look at the provisioning steps for the autonomous. So autonomous transaction processing and autonomous data warehouse are sharing the same provisioning process. So when you are starting the provisioning, the only difference is that you need to make the choice at the beginning if you want to go with the data warehouse or transaction processing. Once this is done, you just have to pick a name and database name. And then you can select the number of CPUs that you want to start with, as well as the amount of storage. You can always scale this value in case of your workloads require more computational power. Then just set password. You have the possibility to bring your own license if you already have already own Oracle database software license, or you can decide to subscribe a new license while provisioning the service. This is always available also for the DB systems. And then we can just go and create the autonomous database. And this will come up in just a few minutes. Very simple process. There is a very few things that you need to, few information that you need to provide. While this is provisioning, we can just quickly take a look at the provisioning process for the DB system. So in case of DB system, the process is a little bit, it's similar. You are leveraging the automation tool. Obviously, in this case, at the end of the provisioning, you will be the administrator of the database as well as the root of the instance where the database is running. Let's pick a name, QuickStart DB. Select an availability domain, select what shape you want to use. Let's get a virtual machine. Select the shape that you want to use. If you want to go with a rack, you just have to change the node count. This is the only thing that you need to do to set up a rack. So it's a really it's really easy to do that. Then select the initial available storage. You can always scale up this value. Provide cluster name. This is optional. Select if you want the license to be included or you are doing a bring your own license. Provide an SSH key, because in this case, as I was mentioning earlier, you will be root of the OS. And then provide information about the virtual cloud network, client subnets, and host prefix. So some of the information needed for the proper configuration of the database, as well as database name, password, and if you want to enable automatic backup. The provisioning process will take around 20-25 minutes in order to provide the instance and to have the instance up and running.
So just to summarize, why Oracle Cloud Infrastructure? So from a technical perspective, we discussed about performance and predictability of the performance. Those are key feature of the OCI and are dependent on multiple elements. The architecture that we used while building the new or second generation cloud platform with the box network virtualization and the possibility to run bare metal nodes with local attachment NVMe, very high performant SSD storage available, and again, very, very important, the fact that there is no oversubscription in the I/O operation for the network and storage, as well as no oversubscription for CPUs or memory. Again, this is definitely the best place to run your Oracle database workload in the cloud with a very wide selection of offering from the autonomous to bare metal to VM, Exadata, and having the possibility to easily provision and leverage rack and data guard and active data guard, as well as being the best place to run your Oracle application like a business suite, GD Edwards, and so on and so on. From a business perspective, again, predictability is a keyword, and in this case is together with a very aggressive pricing. So if you put together the performance and the aggressive price, the ratio is really terrific. Then also the possibility for you to bring your own license and leverage the universal credit model, as well as in general the fact that all the Oracle cloud services are going to run on OCI. Last but not least, the SLA that are contractual SLAs that we are providing not only for the availability but also for performance and management. And those are just some of the main differentiator and unique features that are characterizing the offering. And what is important, I think, it's that it is not just Oracle that says that, but it's also what our customers are saying after having after having started to use the OCI, and so this is as an example what the founder of Cisco Titration said about OCI. Okay, thank you for attending the session, and if you want to try the OCI, put your hands on the environment and do some tests, you can register for a trial environment on cloud.oracle.com/try it.